is Ramisa Anand, and today I will present my NLP project. And the name of my project is Comparative Analysis of Transformer Based and Local LLM Based Review Intelligence System. So, this project basically explores how AI can analyze large sets of restaurant reviews using two different approaches. One is transformers and another one is local large language model, where I've used Olama. The main idea is to understand which method performs better in analyzing real world customer feedback. So next, so these are the tools that I have used in this project. So to collect data, I have used the Epify Google Plays API, which helped me to scrap real restaurant review automatically. And for the data storage, I used PostgreSQL with SQL Alchemy. This allowed me to build structured table with easily updated data whenever new reviews were added. And then on the NLP side, I used transformer model like raw BART for sentiment analysis, BART for summarization, and KeyBART for extracting keywords. Then I compared them with Llama, which runs locally through my old Llama. Unlike transformers, this model can handle all three tasks: sentiment, summary, and keywords. And the main coding and processing were done in Python, so I have used the Python library Matplotlib and Seaborn to do the visualization for the comparison part. Now for the problem statement, the main problem I wanted to solve in this difficulty businesses face when trying to make sense of online customer reviews. There's a huge volume of unstructured text being generated every day. For example, one restaurant can have thousands of reviews and all written differently using slangs, emojis, and mixed emotions. Sometimes can be sarcasm either. So the target audiences for this project is basically restaurant owners, managers, and data analysts who wants insight that what are people happy about, or where can we improve without reading every single reviews. So the another problem statement is cost and time. Manually reading reviews is not only slow but also, I would say, inconsistent, since different people interpret things differently. So lastly, the most existing NLP tool only handle one task at a time. For example, just sentiment or just summarization. I wanted to build an unified AI system that can automatically do all this together: analyze sentiment, summarize opinion, and extract keyword. Next, I wanted to talk about the motivation and the problem. So the motivation behind this project comes from how quickly online platform generates data today. Restaurants and small businesses rely heavily on reviews for growth, but they often don't have tools or time to go through them effectively. Manual review analysis is costly, time consuming, and subjective, while traditional LP system only handles small, separate tasks. For example, one model may detect it if our review is positive or negative, but another model is needed to summarize it. I wanted to design a more effective pipeline, one that uses both transformer models and LLMs, and compare their performance in a real use case. The way I can see how much better large multitask model perform compares to traditional NLP approaches. So now I'm gonna explain the scrap.py. So in this part of the project, I built a Python pipeline to collect Google reviews. And later I stored them in a PostgreSQL using PG engine. So the script connect the PostgreSQL using SQL Alchemy and defines a helper function called upload to database. This function handles insertion or updating data efficiently using a temporary table and a merge operation. So existing records get updated and new ones get added without duplication. And the next thing I did is calling the Epify API token. It basically fetch you fresh Google review data. The data includes restaurants details, category, and reviews, etc. So I got a lot of unstructured data, and I prefer to keep this in my data set for my visualization. So after that, it cleans and structures the data. For example, it generates a unique restaurant ID using hash unique ID, and I've used address and name to create the hash primary key. And also it combines address parts into one readable column, which is full address. So here I have combined the whole address. After that, it separates the raw dataset into two cleaning table. One is a restaurant review and one is restaurant. So finally, both the tables are uploaded into the database using upload to DB function. And yeah, this part of the pipeline ensure that I always have the latest restaurant review data in a structured format ready to further do NLP analysis and LLM analysis. So in this code, I have built a pipeline which will perform sentiment analysis and summarization on Google Restaurant Review using Hugging Face Transformer model. First, I set up a connection to the Postgre same as before, and later it allowed my script to read and store all the Postgre data inside a database. Then I defined a helper function called upload to database. This function takes my data frame and safely upload it into PostgreSQL using merge operation. That means if the record already exists, it updates it, and if it's new, it inserts it, ensuring there's no duplicates. After that, I loaded two pre-trained model from Hugging Face. One's for sentiment analysis called Card Cardiff NLP Twitter Robert and this model classifies each review as positive, negative, and neutral and gives the confidence score. The second model is a Facebook's bar large CNN, which I use to summarize each review into short sentences. Also, I have used Keyboard, a keyword extraction library, to find the top 5 keywords in each review so I could later identify what topics or phrases were driving positive or negative feedback. Next, I pulled all the review text from the restaurant reviews table in PostgreSQL and ran them on one by one through this NLP pipeline. So now I'm gonna explain my LLM analysis code. I have used Olama, which runs a large language model locally on my computer. The goal here is to perform the same type of review analysis as before, identify the sentiment, summarization, the review, and extraction keywords by using a local LLM instead of Hugging Face Transformer. The script first connect to my PostgreSQL database, just like in the NLP pipeline, and then selects all the review from the restaurant reviews table and haven't been processed yet by the LLM model. This prevents duplicate processing and saves time. I created a function called analyze. So I created a function called analyze review Olama, which sends each review to the Olama model. Here I am using Llama 3. Inside the prompt, I ask the model, here's my prompt. So I asked like analyze this customer review, which determines sentiment positive, neutral, and negative. Also provide a sentiment score between 0 and 1. Summarize the review in one sentence and extract 5 keywords. Return valid JSON with key sentiment levels and sentiment score summary keyword list. So this is my prompting, and the model returns the response as structured JSON, which I parsed and cleaned using small helper function called extract JSON blocker. So the reason of doing it, analyzing hundreds of reviews can take time. I implemented a batch process. Every 20 reviews are processed and then upload to the database. So every time there will be like 20 reviews will be uploaded in the database. This makes the script efficient and prevents system overload. Each batch is stored in a table called a review LLM result, and using an observe process that update existing data and add new record automatically. At the end of the run, the remaining reviews are also uploaded, so no data is left behind. This table is later used to compare the result for Olama's local LLM agent. I want to explain a little about my database. So this is my schema Google review, and inside the schema I have 4 table. One is restaurant details, and in restaurant details I have these columns, and later I have another table which is a restaurant review. Under restaurant review I have set these columns, and this is the database for my LLM result, where I have used Olama to create the database. Here I have restaurant ID, sentiment level, and sentiment score, summary, keyword, model name, and created list. So this is my LLM. This is my LLM database, and the last one is the NLP review result. So here I have used almost like same review ID, and here also I've used a review ID. That's my primary key. Now last but not the least, I want to discuss about my visualization. So after processing the data using both models, the transformer based NLP and the local LLM, I moved on to the visualization and comparison part to understand how both systems performed. So in a step 1, I first connected to my PostgreSQL database and loaded both result table on one for the NLP outputs and one for the LLM output. Each review is joined with restaurant information so that we can see which review belongs to which restaurant. In step 2, I have done the cleaning and parse keyword. So here I selected the review text, sentiment level, scores, and extracted keywords for both models. The goal was to align both dataset and make them comparable. Same column, same restaurant ID. In my third step, the NLP model originally gave levels like level 1, level 0, and level 2. So I mapped them into negative, neutral, and positive so the restaurant are easier to interpret. However, for LM data, the model already returned clean text level like positive, negative. So I just capitalized and aligned them. Uh, and then I merged both tables on the review ID and created a flag called same sentiment, which checks whether both models agreed on the sentiment for a review. This helps visualize how consistent or different the two models are. Later, the first bar chart here. So the first bar chart shows how often both models agreed. As you can see, most reviews fall under the yes category, meaning both models agreed on the sentiment most of the time. Only a small portion of the review showed disagreement, which suggests both approaches are largely consistent. And then I plotted a scatter plot comparing the sentiment scores from the NLP and LLM model. Each dot represent the review and the closure. The points are to the diagonal line, the stronger the correlation between two models. This means both models are producing similar confidence level, which identifies sentiment. Next, I compared how each model classified reviews overall. The left chart shows result from the transformer based NLP, and the right side shows the LLM's result. Both models found the majority of review to be positive, but the LLM introduced some mixed opinion, which we can see here, showing it might capture slightly more in a human language. And then here's I averaged the sentiment scores per restaurant and calculated the sentiment gaps, basically how much the two models differ from each restaurant. The yellow histogram shows that most restaurants have a small differences under zero point 0.1, meaning both models agreed closely. And lastly, I generated the word cloud showing the top keywords for positive and negative reviews. So one on the left shows the positive keywords, and one on the right shows the negative keywords. So overall, the visualization showed that both models are highly aligned in sentiment detection. However, the local LLM provides slightly uh, more better outputs and can work offline, making it a cost effective Lastly, the summary. This project present an end-to-end AI pipeline designed to automate the extraction and analysis of customer review from Google Places data. The goal is to transform large volumes of unstructured text into structured, actionable insight, which is revealing customer sentiment, summarizing opinion, and identifying key themes across restaurants. So, this is all from me. Thank you so much for watching.